What's up, everyone? I thought this was really cool. Scientists have captured the highest ever resolution of atoms by zooming in on some atoms of a crystal. Who knows what's going to happen in another 20 years from now with this kind of technology? Let's check this out. Scientists captured the highest ever resolution images of atoms by zooming in on a crystal 100 million times. Wow. Researchers have broken the record for the highest resolution image ever captured of individual atoms, creating a shot that is zoomed in some 100 million times. These images are so fine-tuned, in fact, that the blurring remaining in the shot is the product solely of the thermal jiggling of the atoms themselves. The breakthrough by the Cornell University team built on their previous record, set in 2018, which used a new detector to triple the resolution of an electron microscope. So yeah, I don't really know too much about atoms and digging into the science of all this, but I always figured that electron microscopes were pretty powerful, as most people probably do. But to hear that they actually were able to like triple the resolution of it just by using some kind of detector is really impressive. This previous setup, however, was limited in that it could only image ultra-thin samples, those of only a few atoms in thickness. However, the introduction of a new pixel array detector, which incorporates more advanced 3D reconstruction algorithms, enabled a factor of 2 improvement. This, the team explains, results in an image that has precision at the level of a picometer, or 1 trillionth of a meter. Think about that. All right, so you have a meter, and then 1 trillionth of that meter is a picometer. And this image has a precision of a picometer. And I guess this is the actual picture itself, which is kind of wild. The fact that you can actually see atoms. And we got two here, or is this just like a thumbs up? Oh, I think you can zoom in. Oh, cool. I didn't even see this before when I read this. So this just kind of shows how they're able to visualize this. Interesting. Well, that is not a cool picture right there. This doesn't just set a new record, said paper author and engineer David Moeller of New York's Cornell University. It's reached a regime which is effectively going to be an ultimate limit for resolution. We basically can now figure out where the atoms are in a very easy way. So that's kind of interesting how it's an ultimate limit for resolution. It's kind of like my buddies and I, we talk about video games, and it just seems like at some point, like graphics are going to be as good as they can get. I don't. I guess that might not be true because, like in the 19th century, I believe people were saying that there could be no more inventions, that everything that was going to be invented was invented, and we obviously know that's not true. But it just seems that at some point with video games, the graphics are going to get to the point where it's just like reality. Like you can't have graphics better than reality. Though if you think about it, sometimes video games actually look better than real life, if you know what I mean. Like just like the aesthetics of it, the colors. But enough of that tangent. This opens up a whole lot of new measurement possibilities of things we've wanted to do for a very long time. It also solves a long-standing problem undoing the multiple scattering of the beam in the sample that has blocked us from doing this in the past. I'm going to read this snippet here. Using these images, according to the team, this latest electron ptychography technique could find various applications. For example, it could allow researchers to locate in 3 dimensions those atoms and materials that are obscured in other imaging methods, or single out atomic impurities for close analysis. The latter application could be of particular use for imaging semiconductors, catalysts, and quantum materials. Furthermore, the technique could also be employed to image thick biological cells or tissues, and even to scan synapse connections in the brain, the researchers added. Isn't like Elon Musk using like some kind of like brain reading technology or something? Maybe this will play into like what he's doing in terms of his research. The imaging method used by the team involves a technique called in which a beam, made up in this case of electrons, is repeatedly fired through an object of interest, albeit from a slightly different position each time. By comparing the different overlapping patterns formed by the scattered beam, an algorithm is then able to reconstruct the target object with great precision. We're chasing speckle patterns that look a lot like those laser pointer patterns that cats are equally fascinated by, Professor Mueller explained. By seeing how the pattern changes, we are able to compute the shape of the object that caused the pattern. So what do you think? I thought this was a pretty cool discovery, or just like a further, I don't know if it's a discovery, but it's just a further, I guess, improvement upon previous technology in terms of checking out atoms. Just that the fact that you can see them is, I don't know, to me, pretty awesome. Well, until next time, appreciate you guys checking my videos. Feel free to like and subscribe. And to the 4 of you that have subscribed, I really appreciate it. I'm just blown away by it, to be honest. And it's really cool. Humbly grateful. Thank you.